I welcome you for this presentation. In this presentation, we are going to discuss about cryptographic hash functions. This is the overview of this presentation. That is hash functions, then cryptographic hash function. We will be discussing about uses of hash function, then LAMP port one-time password, then some insecure hash functions, then attacks and hash functions. One major attack on hash function is the birthday paradox or birthday attacks, then cryptanalysis in this hash functions and summary of this presentation. So why we need this hash functions? Because in the cryptographic systems, why we are using this hash functions means in order to provide a more security to the cryptographic technique, we are going in for this hash functions. This hash function is used, we are also daily, we are using this hash function in the net banking and all. If you are entering a password, after entering the username and password, it will be and if we enter the also we enter the captcha and we are just giving a submit, at that time automatically one new password is generated. It looks like this, that is we are getting some huge value, that is also a password only, it is not visible to us. The one new password is generated. What is that password? That is the hash value. For our login credential, one hash value is generated, and based on the hash value whatever we have given, based on the username and password, one hash value is generated, and in our account in the database already it is stored. The hash value of our username as well as password is stored in the database also, and once we log into the system, the whatever the generated hash value is checked with the stored hash value. If both the things are matching, then only we can able to log into our account details. That is the use of hash value in order to provide more security, and we have seen the CAA triad, that is CI stands for integrity. In order to provide more data integrity, we are going in for this hash functions in the cryptographic techniques. So the day-to-day example is in the banking applications, in the login credentials, they are computing the hash value and they are checking with the stored hash value. Then only they are allowing us, they are authenticating us to enter into our account. So how that is working, why, what is the need, and in what different ways this hash function can be used in the cryptographic systems, let us see today. So here hash functions means it condenses the arbitrary message to fixed size. Here you see in the diagram, here we have given a message or data block m of variable length, and always we have to mention the length here, because what is the size of the message? Here message is of variable length, so the length of the message we need to mention. In addition to this, we can also pad the data also. Suppose we are splitting into different blocks. Anyway, that's our wish only, because it is the input is of variable size, and we are dividing into different blocks and we are applying the hash function, and at last in the last block sometimes the message size is not matching with the previous block. In such case we can pad the data also, then we can mention the length. The padding is also possible, but always the hash function just takes the message or input of variable length and it is applied to the hash function, and we are getting the hash value of fixed length. Okay, so how we are mentioning the hash means h equal to the hash value equal to hash function of the message m. H equal to capital H of m. Capital H is the hash function. That for hash function we can use any formula, some XOR operation, something, whatever we are applying the hash function, that function can be applied in, and we have generating a new hash value. And usually we are assuming the hash function as public. So the general hash function only we are using as the hash function, and it is used to detect changes to the message. So because this hash function is providing data integrity, so whatever the changes made to the message, that needs to be detected using this hash function. So I have already told you the banking example. So if anything is changed in the password, then it will show, because the hash value generated from the password, is showing different hash value, and whatever the value stored is also different. So they can easily identify that in the password something is changed, so the data integrity is lost. So something is detected, the changes in the messages is detected using the hash function. So we need a cryptographic hash function, and this cryptographic hash function has two main important properties. One property is one way property, and another one is collision free property. In the one-way property, what we are doing is that it is computationally feasible to find the data mapping to the specific hash. At last, in the requirements of this hash function, we will be seeing in detail about the one-way property. And another main important property is a collision-free property. That is, it is also computationally infeasible to find two data value of the same hash value. Next, this hash function is applied in message integrity check, that is in message digest creations and all. Then that is we are sending a hash of message, that is digest, and this always encrypted and the message is optionally used. And another use of hash function is message authentication code. Another thing is digital signature, that is in order to have the non-repudiation. In the first unit we have seen what is non-repudiation. So in order to provide the digital signature, in order to create as well as to verify the digital signature, we can use this hash function. So these are some of the examples, different ways of applying the hash functions in order to provide message authentication. First case is in A part, what we are doing is, here we are the message is a message as well as the hash of the message is concatenated, and it is applied to the encryption process. In the encryption process, key K is used, that is some secret key is used. Here we are following the symmetric encryption process. Then that encrypted message is sent to the destination, and in the destination side it is decrypted. Then the message M as well as the hash of M is taken, and from the message the hash value is generated, and it is compared with the already existing hash value, and if it is matching, then they are accepting it as a correct value. That is, authentication is claimed. Likewise they are thinking. Next, in the B case, what it is done means message, then the hash of the message. Here hash of the message is encrypted with the help of the key. Then the encrypted hash with the message is concatenated, that is sent to the destination. Here in the first case, if confidentiality need to be maintained, then what we have to do is we have to concatenate message as well as hash of the message, and then we have to encrypt. But here it is providing authentication, so no need to, it is not providing any confidentiality, but authentication is provided here. Next, you see in this case what it has happened means message, then A and B are commonly sharing a secret key, yes. Then with the help of the secret key as well as the message is concatenated, then for that a hash is created, then hash of the secret value plus the message is concatenated, then it is sent to the sender. So different ways we can apply the hash function in order to provide message authentication, and in the last case it is providing both message authentication as well as confidentiality. See here this message, the message is concatenated with the secret key, then hash is produced, then this hash value and the original message is concatenated, then it is encrypted here. So if encryption plays a vital role, then confidentiality is also provided. Otherwise we are just having the message authentication. If encryption takes place means it is providing both the message authentication as well as the confidentiality. Confidentiality is provided if encryption is there means. Next, this hash function is used in digital signatures also. Here the message, then hash of the message is created, then in the hash of the message is encrypted using the private key of A. Then this encrypted message as well as the message is concatenated and is sent here. Here also it is decrypted using the public key. Here there is no encryption has happened separately. So here it is just verification process of the digital signature, that is it is providing authentication for the digital signature, and in the case here you see this part is totally encrypted here. So it is providing both message authentication and confidentiality for this digital signature process. So other uses of hash function, it is not only providing message digest, that message authentication and confidentiality and in digital signatures, it is also used in the pseudo random function as well as in the pseudo random number generator. That is, in the pseudo random function, how it is applied means in order to generate session keys and answers, and in order to produce the key from the password, that is derived keys from master keys cooperatively in order to have the session keys. Then in the pseudo number generator also this hash function is applied. In Vernam cipher we have studied about one-time password. There also this hash function is applied. Then in the session key generation in the pseudo random number generator also this hash function is applied. So in the pseudo random function as well as in the pseudo random number generator also this hash function is applied. And beyond that also it is applied, that is in order to create one-time password file also it is used, hash functions are used. Then mainly in intrusion detection and virus detection also hash function is used. How this hash function is used in intrusion detection means the attack pattern is stored in one table, hash table. Then whenever we are getting a network traffic, at that time the attack pattern, whatever the received attack pattern is checked with whatever the attack pattern stored in the hash table. If there is nothing, then we can easily detect the intrusions or viruses, that is based on the patterns in the hash table. Like for that only in intrusion detection as well as virus detection also these hash functions are used. Example is tripwire. Then in Lamport one-time passwords also this hash function is used. That is mainly this password Lamport's one-time password. Mainly this Lamport's clock, maybe you are aware in this advanced operating system. So mainly in the distributed system only Lamport's logical clock is applied. So how to create the Lamport one-time password, that is also used in this distributed system. That is, the server compromise does not compromise whatever the p value, that is the password p value. Then interception of authentication exchange does not compromise the password either. That is always I already told you the password example. Similarly only for any password in the server side the hash value of the password is stored, and whenever the user is logging into the remote distributed system, because in the distributed system many replicas are available, so wherever the user is logging into the system, at that time for the password the hash value is generated and that hash value is checked with the hash value stored in the server. That is Alice fixed password PA, that is hashes password n times, then the server stores Alice, then n times. When how much time the hash value is generated, each and every time it is stored. Then this hashes password is also stored here. The number of times as well as the hashes password is stored. Then attacker can't get PA from HNF. So if the attacker is getting the hash value of the password, the attacker using that hash value, it is not possible to get the actual message or the actual password. That is the main thing. So here it is used in Lamport one-time password also. So this is about how the protocol is working. That is Alice sends I am Alice, server sends N1, then Alice sends X, where X equal to the hash of that PA value, then server verifies, then server updates Alice to that N minus 1, sends N minus 1, that is N minus 1 hashes the server is sending. Then it is verifying that attacker still can't get PA or authenticate as Alice, because each and every time the Alice is sending, but if it has to match with the stored passwords hash value, then only the system can authenticate whoever is sending. Otherwise the system will see that it is somewhat attacker or opponent, like that only the system will see. So it is always matching with the hash value stored in the system with the used or at that time the login password. There are two simple insecure hash functions, because generally we are telling that hash functions are used for security and mainly for data integrity, but sometimes the hash function can't provide security, but most of the time it is providing data integrity, but sometimes it is not providing security. Let us see one example for this. Consider two simple insecure hash functions, that is the CI, that is bit by bit exclusive OR of every block. XOR operation, you know, it is a odd function, and mainly this XOR operation, one hash function we are using is the XOR operation, that is Ci equal to Bi1 XOR Bi2 XOR bit. For each and every bit we are XORing. That is mainly this is used in this longitudinal redundancy check, and it is effectively used for this data integrity check. This is one way of doing two symbol hash function. One is just the XOR operation, and another one is we are performing a circular shift operation. And for each successive n bit block, we are rotating the current hash value by left by 1 bit. Then we are performing the XOR operation. So these two cases are good for only data integrity purpose, and they are not good for security purpose. So mainly the hash function is for data integrity, but in some times it is used for security also. But in some cases like this, in the XOR hash function or the circular shift hash function, there and all, this is providing only data integrity and not security. So these are some of the requirements of the hash function. That is, already we know the input to the hash function is of variable size and output is of fixed size. So always the input h can be applied, that is hash function can be applied to a block of data of any size, and h produces a fixed length output. Then coming to the efficiency, h of s is relatively easy to compute for any given x, making both hardware and software implementations practical. Then here we are having three properties. Two main properties are one-way property and collision property. So here we are having pre-image resistance, that is one-way property, that is for any given hash value h, it is computationally infeasible to find y value such that h of y equal to h. I already told you that if attacker is getting the hash value, but it is from the hash value, it is not feasible to get the original message. Or if we are using the hash for the password, if the attacker got only the hash value of the password, then from that it is not possible to obtain the original password. So it is providing the one-way property. And next one is second pre-image resistant, that is weak collision resistant. For any given block x, it is computationally infeasible to find y not equal to x with h of y equal to h of x. So because we are having same hash value, but it is not providing the original message, but two different messages are there, but two messages are producing this hash value. By using the hash value, it can't provide the message because that messages are two different messages. For the two different messages, we are getting the same hash value. Another thing is strong collision resistant. In the strong collision resistant, we are having two hash value of same size, and the message is also same. That pair, message pair, x comma y is producing h of y equal to h of x, but we are not able to, if the attacker is getting the hash of the value, the attacker can't get the original message. Whether it is a message pair or same message or different message, it is not possible. And another requirement is the hash function is providing the pseudo randomness property also. Then this hash function is also vulnerable to some attacks like brute force attacks as well as the cryptanalysis. And using this pre-image or second pre-image attack, here we can find y such that h of y equals a given hash value, but it is very difficult using the pre-image resistant. Then collision resistant, find two images x and y with the same hash, so h of x equal to h of y. Here value 2 power m by 2 determines strength of hash code against brute force attacks, but 128 bits is inadequate, but 160 bits we can suspect the message. That is, here always it is depends on the size of the message as well. But suppose if you are using 128 bits, it is inadequate to find out the, or inadequate to perform some attacks, that is brute force attacks or subscript analysis. But 160 bits if you are providing, then we can suspect, or using brute force attack, it is possible to find out the value. So in spite of all the security measures, but all the cryptographic techniques are vulnerable to some attacks in some sense. So for all the cryptographic techniques, brute force attacks is the only possible attack. Okay, so in based on the bit size also, it is possible to find out, or the hash function is vulnerable to attack. So another main important is birthday paradox. That is a one type of attack happen, that is a birthday attacks. That is, what are the chances we get a match? That is given a group of students, what are the possibility of having two people born on the same day. So based on that only here also, this is also related to the that problem. So this hash function is related to the that birthday paradox, that is we are having n distinct values and k randomly chosen ones are there. Then what is the probability? That is probability of a randomly selected values from 1 to n have at least one match. At least there is a one match. Here you see xi dash is equal to yj dash. Here we are trying for more possibilities, but sometimes we will be getting one match. That is the birthday attack. So for p of n comma k greater than 5, we need k approximately n power 1 by 2 value. So we need double time the number of bits in the hash value. Then it is possible. That is vulnerable to the attack. Then this hash function, we can have the cryptanalysis, that is brute force attack. So cryptanalysis, how we are performing means the cryptanalytic attacks exploit some property of the algorithm so faster than the exhaustive search, because a brute force attack means we have to search for all possible combinations, but the cryptanalysis, it is doing somewhat fast because some methodology we are applying into and we are finding. So in the hash functions, we are using the iterative structure, that is we are processing the message in blocks including the length. So attacks focuses on collisions in the function f. So here this is one example of the secure hash function. So here we are having the message y naught of length that is b. Then we are having the initialization vector with the chaining. Then the length of that is n, that is passed to this function. Likewise, we are producing. So we are having the chaining, that is cipher block chaining we are having. That is the chaining vector we are producing finally. So this is using some cryptanalytic techniques, it is possible to perform some attack in this hash function. Then we can use the block ciphers as also hash functions, because what is the hash function we are using? Because we are talking about hash function, what hash function we are using? The block ciphers can also be used as hash functions. That is, we can use block ciphers as hash functions. That is, first we are using h naught equal to 0 and 0 pad of the final block. Then finally we are computing hi equal to emi of hi minus 1. The block ciphers, block chaining we have applied. So we can use this encryption mi of hi minus 1 and use the final blocks as the hash value. This is similar to the cipher block chaining but without a key. In the cipher block chaining, we are using a key, then only we are performing. But here we are performing the encryption process without a key, but the concept we applied is based on cipher block chaining. But this resulting hash is very small, that is 64 bit. So both due to its direct birthday attack and meet in the middle attack, other variants is also possible here. So this is the general structure of block ciphers, how it is applied as hash function. The message is applied to the encryption process and the hash value is applied. Without the help of the key, we are performing the encryption process with only the message as well as the hash function. So in this presentation, we have discussed about the hash functions, cryptographic hash function, then uses of hash function, then Lamport one-time password, then insecure hash functions, then attacks on hash functions, then one attacks, that is birthday paradox or birthday attacks, then how the cryptanalysis is performed using this hash functions. In the next presentation, we will be discussing about one famous cryptographic hash function, that is secure hash function, that is SHA algorithm we will be discussing. Thank you.